Okay, some more worthwhile stuff. We're going to work our whole way through trigonometry, and uh, maybe you know what? Maybe a really cool thing for you to do would be to look at the beginning of your trig book and then look towards the end and go, "Oh my God, I'll never be able to do this." Because you will. You'll actually be able to do this. It's actually not horrible, but it builds, and you can't do it without gathering the pieces. So, if you don't mind, let's start with the, let's start with the first kind of six pieces, and it's the definition of a trig function of an acute angle. So we're going to look at the acute angles of a right triangle. So what we find is this. So here's a right triangle. Right? Here's our right triangle. Here's a right triangle. And what this says is this, that, well, here are the functions, right? We have sine of theta, right? That's this ratio where theta is the angle that we're interested in. We have cosine of theta. That's a different ratio. And we have tan of theta. So these are not really difficult to deal with. We just have to know what they are. So you know what? Let's start at the end. So what I'm going to tell you is that sine of theta is the ratio of side opposite to the hypotenuse. And this is adjacent over hypotenuse. And lastly, it's opposite over adjacent. So this is how we memorize this, and it's as stupid as anything, but it works, and as weird as it is, your parents and your parents' parents, if they ever learned kind of advanced geometry or trig, they learned it this way. So we're going to take, when we want sine, we're going to say sine is opposite over hypotenuse. So there's our acronym or our mnemonic device. And when we want to memorize what the cosine ratio is, we say, well, cosine is adjacent over hypotenuse. So it's C-A-H, chi. And lastly, we have tan. And tan is opposite over adjacent. So the mnemonic device has always been SOHCAHTOA. And I remember all the stories about how we were supposed to memorize that, but that's a good start. So yeah, I'm not usually a big guy on mnemonic devices, but this is actually one of those mnemonic devices that has been around and really stood the test of time. And the reason that it has is because, well, frankly, it's worked for all of us. So that's how we're going to memorize this. Now what we have to figure out is, what the hell are you talking about? So start with this. Start with, here's our triangle, isn't it? And I'm suggesting to you, I'm telling you, this is a right triangle. I don't know exactly what these are here, but they're acute, right? They have to be less than 90. Because when we add this, this, and this, we're going to get 180, right? So at least, right, these both have to be less than 90, don't they? Okay. Okay, so here we go. So let's say that the angle that you're interested in is the angle created right here. And then you're going to just call that angle theta. So this is what you have to have learned. So when you're looking, you have to figure out, where the hell, where is opposite? Well, opposite, when you're at theta, go straight out of theta, straight to here, and that's always side opposite, right? If we have a right triangle, then, this is by definition what we're looking for, right? This is a right triangle, so we know the hypotenuse will always be the longest. So this is opposite, so we know this is always going to be hypotenuse, and this is adjacent, right? So you're like, oh, I can find that. So if I find cosine, right, use the same thing. So if you were looking for this, if you're looking for sine, here's opposite, here's hypotenuse, so it would be this number would be a number here, and this number here would give you that ratio. Or cosine of theta, you take the value of the adjacent side over the value of the hypotenuse side, and you'd have this, okay? All right. The thing that I do want to warn you about that kind of gets people is that your angle theta, this angle theta here, means the angle of interest. Well, if you're looking at the acute angles of a right triangle, well, this is an acute angle, but this might be the angle that you're interested in, right? So you might say, well, no, Charlie, this is theta. This is the angle I'm interested in. In which case, look, everything except for hypotenuse switches. Remember, if you come right out of the right away from theta and go straight out in front of you, right there. This, because of where the angle is, this becomes side opposite. This is always hypotenuse, and the remaining side becomes adjacent. Now, I'm not trying to confuse you. I'm actually trying to avert future confusion by telling you it depends on what angle you're interested in. If you're interested in this angle or this one, right? Because the opposite side is not always in the same place, if you will. It depends on where you're looking from. So if this is your theta, then this is opposite. If this was your theta, then that is your opposite. And I'm sitting there going, oh my God, I hope I didn't make it worse. But this is kind of one of those things that we have to have. I'm begging you now, because this is going to get trickier, that you have to start memorizing these things right here. It will really help, because as the game gets going faster and faster, you're not going to have time to go back and memorize this. So work on this now. Use this mnemonic device and kind of think about this. Think your way through this a little bit, okay? All right, you guys. I'm going to go on to this next video in just a second, and what I want to talk about is the reciprocal identities, and I hope you'll stay with me, because it's where you go next. And then we're going to work on that, and then we're going to do some discovery. So I hope that you're with me, and I hope that you've subscribed. And your comments, especially if they don't have to be great comments, but if they're constructive, man, I would love to hear from you. So thanks.